This is Precalculus Chapter 7, Lesson 1, homework help video. I'm going to work some even problems to help you get started on your homework. So I'm going to start with problem number 2, all right? So it says graph the cosine of t, and here's the interval. We want to start at pi, we want to end at 3 pi. Remember, we have the 4 key points in there, all the quadrants. So it's 0, pi over 2. It's the axes, right? 0, pi over 2, pi, 3 pi over 2, back all the way back to 2 pi. All right. So we're going to start at pi. All right, at pi. Remember, we're going to go up to 1, down to -1. So then we'll go, bring this out some. I'm going to make this a little smaller. That's 3 pi over 2. That's 2 pi. So this is going to be 2.5, which is 5 halves pi. This is going to be 3 pi. Oh, there we go. I was thinking I needed to go further. All right. I don't. It's okay how small it is. All right. So we think remember, your radians go on the x-axis. The ratio is on the y-axis. At pi, on the unit circle, that's over here. The cosine is -1. We'll go to -1. At 3 pi over 2, that's here. It's 0. And then at 2 pi, it goes back up to 1. So there's 2 pi. Continuing around, this will be 5 pi over 2, like if we're going around and around and around, all right? So then that's 0. And then at 3 pi, that would be like we're coterminal to pi. So it's back to 0. All right, so just on this interval, the cosine curve looks a little like this. All right? So it just is telling you what interval. It's telling you the first point you want to graph and the last point you want to graph. All right? All right, so number 8. Let me just look at your home. Yeah, you just had to do 1 through 3, so you have to do 1 and 2. All right, number 8. For what values on the interval? Okay, so now it's looking at an interval from -2 pi to 2 pi. That's interval notation, so it includes those values. All right, is the cosine of t equal to 0? So it's asking for the values of t, the radians, where the ratio, it's asking for radians. What radians in that interval is the ratio of the cosine 0? Right, the cosine, so let's go from -2 pi all the way to 2 pi. Think of the unit circle. The cosine is 1 here, 0, -1, 0. This is pi over 2. This is 3 pi over 2. All right, so I know the closest one to 2 pi would be 3 pi over 2, and then pi over 2. But it wants to go also clockwise this way. All right, so when we're going clockwise, this would be -pi over 2, and this would be -3 pi over 2. So then it would go to -pi over 2 and -3 pi over 2. So the distance that this repeats, look at the distance here, is pi. The distance here is pi. It's going to be something we'll need to understand. The distance here is a whole pi. All right, so every pi plus and minus from pi over 2, the cosine is going to always equal 0, that ratio, all right? That's number 8. What's the maximum value? All right, number 10. What's the minimum value of the sine? It's -1. It will only be -1. That's the smallest value of y for the sine. Remember I told you, we're talking about f of t, or the range, what's on the y-axis. Unless it's been transformed, the highest value of the sine will be, the sine of t will be 1, the lowest -1. Same for cosine sine. Same for cosine. The tangent will go from -infinity to +infinity. All right. Number 12. What is the y-intercept of the graph? Well, think of the curve. Think of the sine curve. Remember, sine curve starts at 0 and it goes up. So here's your y-intercept. Your y-intercept is at 0. What is the y-intercept for the cosine? Remember, the cosine starts at 1 and goes down. So the y-intercept would be 1 for the cosine, all right? Number 16. For what values on this interval, all right, let's write the interval down. I'm on 16. Could have given you the page number 484. Okay, here's the interval from -3 pi to -pi. Is the cosine of t decreasing? All right, so let's think of the cosine curve. My iPad is. All right, remember we'll go ahead and graph this. This is pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2 to 3 pi. We'll go backwards 2. So this is -pi over 2, -pi. All right, we go up to 1, down to -1. Remember the cosine starts here, 0, -1, 0, 1, 0, -1. We'll go back here, here. Okay, increasing. At 1, we're going to start decreasing, right? We're going to decrease here. This area is decreasing. So it's decreasing from 0, we need the radians, from 0 to pi. All right, then it begins increasing. Look at 2 pi, and remember that means union, 2 pi all the way to 3 pi. All right, so on those intervals, it is decreasing. Oh wait, I did this backwards. Okay, but you get the idea. I did it from -pi to 3 pi. All right? It wanted -3 pi to -pi. Anyway, you get the idea, right? We can start anywhere. And it just wants the intervals on which it is decreasing. It could have asked for the intervals on which it is increasing. That would be from -pi to 0, from pi to 2 pi. All right? That's number 16. Number 20. Well, not really number 16. I made it up, huh? All right, number 20. It says, find the exact values for which the given statement is true. The tan of t equals 0. Okay, remember for the tangent, its period is pi. It repeats. I was going to write pi there, but pi doesn't go there. Pi over 2, rather. Negative pi over 2. Every odd half pi for the tangent, there is a vertical asymptote, and it looks like this. So here, this would be 3 pi over 2, and this would be pi. Here would be another asymptote, and it would be right here. So it's going to be 0 at 0. It's going to be 0 at pi. It's going to be 0 at negative pi. It's going to be 0 at 2 pi, at 3 pi. Every factor of pi and 0, 0 plus pi, however many pi, could be 0 plus 10 pi, 0 plus 20 pi, 0 plus 12 pi, 0 minus pi, 0 minus 3 pi. It's always going to be 0. All right, so the value of t is going to be 0 plus minus k pi. Any value multiplied by pi, plus or minus. All right, does that make sense? K is any integer. And your textbook uses n instead of k. Always use k. All right, number 26. Where's the cosine? Let's look at the cosine. 26. Every place where the radians has a ratio of 0 for the cosine curve, all right? So let's draw one. Remember our 4 key points: pi over 2, pi, 3 pi over 2 to 2 pi. And then we'll do negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, 1, negative 1. We start at 1, 0, negative 1, 0, 1. I go back, 0, negative 1, 0, 1. If I were to graph it, remember it's just continuous. All right. So I want to look at the distance from here to here. And then we'll look at the distance from here to there. All right, from negative 3 pi over 2 to pi over 2 is really a whole 2 pi, because 3/2 a pi plus a pi is 2 pi. So from pi over 2, I can add or subtract any value, any number times 2 pi, and the cosine of t will always be 0. All right, so t is pi over 2 plus minus 2k pi. All right, the same is true of 3 pi over 2. The distance from negative pi over 2 to 3 pi over 2 is 1/2 a pi plus 3/2 a pi, which is 2 pi. So I can take t is also equal to 3 pi over 2 plus minus 2k pi. All right, so for the cosine and the sine, you're going to always have 2 values, plus minus 2k pi. It's always going to repeat. Why? Because we go around the unit circle. All right, so look, right here, the cosine is 0. plus 2k pi. It's 0 again. I could go minus 2k pi. It's 0 again. Around and around and around, right? It's also 0 here at 3 pi over 2, right? I could go around another 2k pi and 2 pi, and it would be 0. I could go around 5 times, it'd still be 0, or I can go backwards and it's 0. That's why they're called periodic. They're repetitive over and over again, every 2 pi. But for the tan, because it has that asymptotes, it's not like the sine and cosine. So every value, the distance between them is always going to be pi. All right. Number 28. When is the sine of t equal to 1? All right, let's graph it so we can see it. We go from 1 to -1. Remember our 4 key points, pi over 2, pi, 3 pi over 2, 2 pi. Let's go in the other direction. -pi over 2, -pi, -3 pi over 2, -2 pi. Remember, it starts at 0, up to 1, back to 0, down to -1, back to 0. The other direction goes down to -1 because we're going clockwise, to 0, up to 1, back to 0, such that it looks like this. All right. So look, in one sine curve, the value is 1 only at one point. That's true for 1 and -1. Every other value has 2. All right. But 1 and -1 only has one value. One time it hits 1 and one time it hits -1 on a single curve, right? In one single cycle. And the distance is 2 pi. So t actually only has one solution here. It's pi over 2 plus or minus 2k pi. Because I can go 2 pi back. That's just going around the unit circle clockwise. And I'm going to hit the ratio of 1. I can go forward 2k pi. I'm going to hit the ratio of 1. All right, 36. List the transformations. Okay, let's think. All right. List the transformations. State the domain and range. And I did 36 and 42. 36. Well, I said I would do 36 and 42. All right, 36. So we go from the sine of t to -3 sine of t. All right, that is a vertical reflection across the x-axis. So vertical reflection across the x-axis, and this is a vertical stretch by a factor of 3. Remember, this is my amplitude. We're going to learn that word later, but I'm going to go ahead and... All right, so instead of going up to 1, down to -1, we're going to go up to 3, down to -3. We still have our key points. Pi over 2, pi, 3 pi over 2, 2 pi. I'll just do one cycle this way. We're still going to start at 0, but instead of going up, we're going to go down. Down, down, back here, up, back here. So that it looks like this, and it's vertically stretched. All right. So the domain is all reals. It goes from -infinity to +infinity. Every x value. All radian. All right. But the range the smallest number is -3, and the biggest number is +3. All right, so when we've been stretched, we're going to go down lower and up higher. All right. The range is going to be affected by our vertical stretches and by our vertical shifts up and down. The domain will always be all rails. All right, 42. Here's the transformation. All right, that is a vertical stretch. So our amplitude, we're going to go up to 5, down to -5. Except that we've been vertically shifted up by 3. All right. So, should have made this smaller. All right, I'm going to make this smaller. So instead of starting at 1 and this being my x-axis, I'm going to move it up 3. So that's 1, 2, 3. So it's at 4, right? And now the one right below it becomes my imaginary new x-axis. But instead of just going up 1 from that imaginary x-axis, we're going to go up 5. So that's 1, 2, 3, 4, 5. So it's 4, 5, 6, 7. We're going to go start at 8, and we're going to go below that new x-axis 5. 1, 2, 3, 4, 5 to -2. Yeah, I made those a little bit bigger, huh? So that if this was pi over 2, pi, 3 pi over 2, 2 pi. See, I've shifted my x-axis up 3. I've shifted my point up 3, but instead of just going up 1, we're going to go up 5. So I'm not going to go up. I'm going to go up 3. I'm going to go up from my new x-axis 5. So it's 3 to 8. All right, so start there, here, here, and here. All right. So that now I can see, instead of going from just -1 to 1, my domain is still all rails. So from -infinity to +infinity, but my range is now from -2 to +8.